Hi, we are learning about functions today. So I know I've got this when I can identify relations, domains, and ranges, identify functions, use the vertical line test, and use function notation. So key vocabulary is relation and domain and range, function, vertical line test, independent and dependent variables, and function notation. So a relation is just a set of ordered pairs. The domain are all the x coordinates of the set, and the range is all the y coordinates. So identify the domain and range of the relation. Okay, so all you have to do is find the domain. So the domain are all the x coordinates, and the range are all the y coordinates. So your domain is going to be 4, -4, 2, and 10. And the range is all the y coordinates, so 9, 3, and -5. And notice that I did not write the 9 twice, even though it appears twice. So what that means is if you have a number that's repeating, you only write it once. All right, find the domain and the range of the following relation. So obviously this is a little different. So the domain and the range. So the domain is all the input and the range is all the outputs. So the domains are the polar bears, cows, chimpanzees, giraffes, gorillas, kangaroos, and red fox. And the range is 20, 15, 10, and 7. Okay, so this one is for you to do. Determine the domain and range of the relation. Go ahead and pause the video, write it down, and I'll be back in a second. Okay, so the domain for C is 2, 0, -1, and -2. And the range is 3, 0, -5, and 6. The domain of D is 3, and the range is 1, 2, 0, and -6. Honestly, I like you to put them in order from least to greatest, but I don't think it matters in the curriculum that we're doing. Okay, a function is a set of ordered pairs that assigns each x value to exactly one y value. Some relations are also called functions. So basically, if for a relation to be a function, no x's can repeat. So given the relation 4, 9, -4, 9, 2, 3, and 10, -5, is it a function? Since each element of the domain is paired with only one element of the range, it is a function. So then at the bottom I have note, it is okay for a y value to be assigned to more than one x value, but an x value cannot be assigned to more one y value. So basically no x's can repeat, the y's can repeat, but no x's can repeat. So in a graph, to be a function, you have to be able to, a vertical line can be drawn so that it intersects the graph only at one point. If it does intersect it at more than once, it's not a function. So for example, in this one, use the vertical line test to determine whether the graph is a function. Yes, it is a function since the vertical line is only going to intersect this graph at this one point. 2, use the vertical line test to determine if it is. Yes, it is because it only intersects right there. Use a vertical line test to determine. You do it. Pause. And it's no because it intersects at 2 places. So which of the following graphs are the graphs of functions? So which one of these are functions? So A, B, and D are functions. C is not because it intersects right here and here. And E, it has an infinite amount of places that it's going to touch on a vertical line. Now, D, you would think that, okay, you're saying, well, this might look like it goes vertical, but it never actually is completely vertical. So A, B, and D are all functions. Is that a function? The answer is no, because the X value repeats at 0. So you can see that you have this point right here at 0, 3 and the point at 0, -2. They are on top of each other. So that does not pass the vertical line test, and which also means the X values are repeated. So since the graph of a linear equation is a line, all linear equations are functions except for those whose graph is a vertical line. So we're going to do A and B together, and then you're going to do C and D. Okay, so A, which of the following are linear functions? So is A? Yes, because that graph would look like this. So yes. B, is that function, is that equation a function? Yes, it is. Okay, and then you're going to do C and D, so you try. And the answer is A, B, and C are functions because their graphs are non-vertical lines. D is not a function because it is a vertical line. Now we're going to go into function notation. So we've done this a little bit to denote that y is a function of x. We can write it as y equals f of x. So the notation means that y is a function of x, or that y depends on x. For this reason, y is called the dependent variable and x is the independent variable. So what do you do with that? All right, if f of x, it's not fx, it's f of x equals x squared minus 2x, find f of -3. All you do is you plug -3 in for every x. So you're just going to go -3 squared minus 2 times -3. This is just kind of like what you're doing. You don't actually do any math with that. So -3 squared is a +9, and -2 times -3 is 6. So 9 plus 6 is 15. So the coordinate then would be, all right, if x equals -3, y equals 15. So that would be your final answer. All right, find the value of f of -3 if f of x equals 3x minus 2. So we're just going to replace x with a -3. That would be -9 minus 2 is -11. So the coordinate would be -3, -11. All right, C, you go ahead and try this one. Pause it. And you should have gotten, okay, so if I plug in a 2 for x, I would get 4. If I plug in a 0 for x, I would get -2. So 2, 4, and 0, -2 are my answers. All right, so how do you find the domain of a function? So again, the domain is all the x values of the function. The range is all the y values of the function. When an equation is written in function notation, you can find the domain by setting the denominator equal to 0 and solving for the variable. The domain would equal all real numbers except where the denominator equals 0. If there's no variable in the denominator, the domain was all real numbers, unless it's a vertical line. Think of what the graph of the equation would look like. So when you're finding the domain right here, all you do, if you have a denominator, is set the denominator not equal to 0 and solve. So the answer to A would be all reals, signified by the R with the line through it, except where x equals 0. Okay, and then G doesn't have a denominator, so you would just say all reals. So the domain can be everything. Let's see, let's back that up. Okay. So let's try another one. Find the domain and the range of the function graph to the right. All right, so remember the domain is all the x coordinates and the range is all the y coordinates. So the domain, you're going from -3 right here to a +4. So the domain is -3 is less than x or equal to x is less than or equal to 4. Now I can also write this in interval notation. We'll get more to that in the future, but you have a bracket at -3 and +4. It's a bracket because it's or equal to. If it was just less than, it would be a parentheses, but we'll talk more about that later. And the range are all the y values. So you're going from your lowest y coordinate is right here at -4, and you're going all the way up on this until it's +2. So from here to here, your y values are from -4 to 2. And then I could also write that -4, comma, +2. All right, so find the domain and the range of the function graph to the right. So the domain actually is all real numbers because these constantly go out to the left and the right. So you say all reals. Your range starts at -2 and keeps going up. So your range is just y is greater than -2. Okay, you go ahead and do this one. Pause it and do it. All right, and these are your answers. So, okay, so let's go ahead and do some of these. Find the domain and range. Go ahead, I'm sorry, just find the domain. Go ahead and pause it. Okay, so G would be all reals. H would be all reals except where x equals 3. Because if x equaled 3, the denominator would equal 0, and you can't have that. And then letter I is all reals also. Okay, number 5. If f equals 4, write a corresponding ordered pair. All right, so here's the deal. You know that it's f of x, right? And f of x is the same thing as y. So if I look at that and I take this function, then my 4 would be the x and my 10 would be the y. So that's all you have to do. So I know I've got this when I can identify relations, domains, and ranges, identify functions, use the vertical line test, and use function notation. Do you really understand it though? If a relation is a given set of ordered pairs, how can you tell if the relation is a function? You check to see that each x coordinate is paired with only one y coordinate. How can you use a vertical line test to determine if a graph is a graph of a function? Check to see that any vertical line that can be drawn through the graph intersects the graph in no more than one point. And that is it. I really hope you understand. If you have questions, just let me know.